This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on improper integrals, part 2. We're going to examine the integral from 0 to infinity of e to the negative 5x. And there are no internal discontinuities on this function. E to the negative 5x is defined for all real values of x. It is an improper integral, though, because it is going to infinity. We're going to need to go ahead and rewrite that as the limit as b goes to infinity. But before we do that, let's take a look at a graph. Do we think from the graph that there's a chance that this will converge to a single number, or do we think this is going to continue to grow without bound? So here's the graph of e to the negative 5x. Notice it is decreasing very rapidly. And even on our graph with pretty good precision, we're looking at each box represents what, a fifth. It sure looks like that red graph is directly on the y-axis. Of course it isn't. It's asymptotic. It never actually touches the x-axis, but it's certainly moving down very quickly. So if you're looking at this piece here is considerably less than a half, and then the stuff that's out there beyond sure doesn't look like very much. But let's take a look at what this integral is going to wind up being. So again, we've got to write it as a limit, so let's do that. Limit as b goes to infinity of the integral from 0 to b of e to the negative 5x dx. Remember, the integral of e to the kx dx is e to the kx over k. So the integral of e to the negative 5x would be e to the negative 5x over negative 5. Then we've got to evaluate that at b and at 0 and subtract. Now this negative 5 downstairs is really 1 over negative 5, so negative 1/5 can come out in front of the limit sign. And what does e to the negative 5x mean? That, of course, is 1 over e to the 5x. So we're going to take 1 over e to the 5x evaluated at b and evaluated at 0 and subtract. So we'll have negative 1/5, limit as b goes to infinity, 1 over e to the 5b minus 1 over e to the 5 times 0. 5 times 0 is 0, e to the 0 is 1. So this whole piece just becomes 1. But this is the interesting piece. As b gets large, 5b gets large. So e, 2.718 to a large number gets very large. 1 over a very large number is going to 0. So we have negative 1/5 times 0 minus 1, and that total area under the curve is 1/5. Can we believe that when we look at the graph? Total area from 0 to infinity is 1/5. Again, this is well less than a half. That may be pretty close to a fifth, because the stuff that goes beyond is negligible. So yes, I think the 1/5 answer is pretty reasonable. The next question we'll look at is the integral from negative infinity to infinity of 1 over 1 plus x squared. This has infinities on both ends. We're going to need to pick a point in the middle and do two limits that way. So negative infinity to 0, 0 to infinity. And if either of those diverges, then the entire integral diverges. But let's look at the graph to see if there's a chance this could converge. From 0 to infinity, does this look like this might converge? I guess it's possible. The red graph is coming down to the x-axis fairly quickly, so that could be bound, but maybe not. We're going to have to do the analysis. From negative infinity to 0, the shape is exactly the same, so I will expect those two integrals, if they converge, to converge to the same number. So let's go ahead and do our analysis and determine whether or not this converges. So here's our question, and as I mentioned, we need two limits. Limit as a goes to negative infinity, from a to 0. Limit as b goes to infinity, from 0 to b, because we're working off of this guy first. Negative infinity to 0 plus 0 to infinity, and then put the limits in as we talked about. A to negative infinity, b to infinity. Once we're here, we have to remember what the antiderivative of 1 over 1 plus x squared is. The derivative of inverse tangent of x is 1 over 1 plus x squared. So the integral of 1 over 1 plus x squared is inverse tangent of x. So we'll have inverse tangent of x evaluated from a to 0, subtract inverse tangent of x evaluated from 0 to b, and subtract. So limit as a goes to negative infinity, arctan 0 minus arctan a. Limit as b goes to positive infinity, arctan b minus arctan 0. Inverse tangent of 0 is 0 because tangent of 0 is 0. So we have a 0 here and we have a 0 here. But what about the inverse tangent of a as a goes to negative infinity? How can we figure out what happens to the inverse tangent of a as a goes to negative infinity? Or the inverse tangent of b as b goes to positive infinity? Well, think of the graph of tangent. As x gets closer to pi over 2 from the left, the values of the tangent go to infinity. So pi over 2 should be an issue. And as x approaches negative pi over 2 from the right, the values of the tangent go to negative pi over 2. Now looking at the graph of inverse tangent, this is what it looks like. We have these two asymptotic lines. And what are they? Indeed, that's y is pi over 2 and y is negative pi over 2. So as x goes to infinity, arctangent of x is getting closer and closer to pi over 2. As x goes to negative infinity, the y values, arctangent of x gets closer and closer to negative pi over 2. So back to this thing, as a goes to negative infinity, arctangent of a is going to go to negative pi over 2, but we have 0 minus negative pi over 2 there. This piece will go to pi over 2 minus 0. 0 minus negative pi over 2 is pi over 2 plus pi over 2, and the result of that is, of course, pi. And that will conclude this lesson.